To another series of lessons for computer science ordinary level. I am your computer science teacher, and my objective is to demystify most of the disturbing concepts in O-level computer science. And having shortlisted the problems that students face in O-level computer science, algorithm problem solving and programming remains a challenge. So in this series of lessons, we will start by introducing computational thinking and problem solving to algorithm. So for this first lesson, my dear students, we are going to start with module 1, problem solving and coding 3 as per the syllabus. And the first lesson will be on computational thinking. And when we look at our lesson plan for this series of lessons, we are going to notice that we will have an introduction, we'll have lesson content, we'll have practice exercise, we'll have conclusion, we have assignment and revision question. My dear students, at the end of every lesson, you will always have an assignment or revision questions for your review. So let's write on. What is computational thinking all about? Computational thinking is a problem-solving process that includes a number of characteristics and dispositions. Secondly, computational thinking is essential to the development of computer applications, but it can also be used to support problem solving across all disciplines. So computational thinking is a problem-solving process. So we are thinking of problems in terms of computing. So that's computational thinking. And also it also helps in the development of computer applications, but it can also be used to support problem solving across all disciplines, not only computer science. Computational thinking is applied in areas like humanities, maths, and science. Now, students who learn computational thinking across the curriculum can begin to see a relationship between subjects as well as between school and life outside the classroom. So, my dear students, this concept of computational thinking does not only limit to computer science, it cuts across other disciplines, and there is a relationship that exists between computational thinking and other areas of studies like mathematics, like the sciences. So while you are studying computational thinking, you see that you can apply it in other disciplines apart from computer science. Now, what are the components of computational thinking? Now, the first three components, which are but popular, we have decomposition, which is breaking down data, processes or problems into smaller and manageable parts. This is very important to understand. Breaking down data, processes, it could be a problem, into smaller manageable parts. The second is pattern recognition. Observing patterns, trends, and regularities in data is very important. For example, patterns of numbers, patterns of shapes, patterns of structures. So it is very important. Then there's abstraction, removing unnecessary detail from a problem to focus on what is important. So abstraction is, for example, I always use this my simple example. You can learn how to drive a car without necessarily understanding the mechanics and the mechanism of car manufacturing. So those details have been hidden away from a car owner. So a car owner must not necessarily be a mechanical engineer. So that is abstraction in computing. Then the fourth is algorithm. Developing step-by-step solutions or rules for solving problems or completing tasks, which of course it is the most popularly used component of computational thinking, as we are going to be using it in problem solving. We proceed. Areas of application of computational thinking. The first area is mathematics. Using algorithms for calculations, recognizing patterns in numbers. Sciences, modeling simulations, analyzing large sets of data. So we can use computational thinking in these areas. We have humanities, identifying themes or patterns in historical events or literature. Then we have art, creating algorithms for digital art, processing techniques. So these are some of the common areas where computational thinking is applied. Now we should take into consideration here that computational thinking is not only used in mathematics, and there is sciences, there is humanities, there is art. So in every sphere of life, you are going to make use of computational thinking. So it is a topic that you should pay attention to as it applies across many disciplines. The importance of computational thinking. Why is computational thinking important? First thing, problem-solving skills. Computational thinking enhances the ability to solve complex problems by breaking them down into more manageable parts, the same way decomposition is telling us. So, if you are good in computational thinking, it will help you in problem solving. That is, it will give you that skill, that ability to solve complex problems by breaking them down into small parts and then bringing them back together to form the original part. Now, it is also a foundation for computer science. We are all computer scientists, and it is essential for programming and software development. So, as we'll be studying programming, you'll notice that we don't just move to the machine and start coding. We have to first of all analyze a problem, design that problem before we start coding. So, computational thinking helps us to build these analysis and design skills. So, it is very important as developers, we need to understand computational thinking. The importance continue. Interdisciplinary approach. It encourages application of knowledge across various fields through abstraction and pattern recognition. So as I said earlier, computational thinking is not only used in computer science. You can apply it across other disciplines. Adaptability. It fosters flexibility in thinking, which is necessary for adapting to rapid changing technologies. So most of us would like to continue as software engineers or computer engineers in the future. This is a very important topic to consider when you are aspiring for a career in software or tech. Now, in summary, computational thinking equips students with a versatile skill set that helps them navigate through both academic challenges and real world. Remember, if you have a good mastery of computational thinking, you apply it in real life, not necessarily only in classroom. That's why we say computational thinking takes you from beyond the classroom to the real world. Secondly, computational thinking is used in logical reasoning and innovative approaches inspired by how computers solve problems. So if you and I really want to start understanding how computers manage to solve problems, we must start from computational thinking. So we need to start thinking like how the machine should act. So that's computational thinking. How do machines solve problems? So this takes us to that. And lastly, computational thinking remains a very important skill every computer science student or educator should have. So you and I must have computational thinking skills, especially in the field of computing, for us to be able to develop softwares, for us to be able to develop systems that can solve day-to-day problems. So to end the lesson, my dear students, we have provided some revision questions at your disposal so that you can use for revision. So the first question is, what is computational thinking? Outline the key components of computational thinking. Describe the areas of computational thinking. State and explain the importance of computational thinking. When you must have answered these 4 questions, then without, so it will help you, to actually have maybe some tests to understand if you have actually have a mastery of the concepts taught in this first lesson. So take your time, read, go through the video. After going through the video, sit down, answer the questions, and we will always provide answers to these questions in our follow-up lectures. And so, thank you very much for watching. This has been our first lesson. See you guys in the next lesson. Remember, we are here to demystify your most difficult concept in computer science.